All right, what's up, Buckaroos? This is Mr. B. We're going to discuss at this time topic 5-5, which is graphs and functions. We're going to kind of bring functions to the next level, which is to incorporate them with tables and incorporate them in graphs as well. So example 1 says that it's having a sale. The first pair of shoes sells for $40. The second pair sells for half price or $20. The next pair sells for half of that, and so on. Make a table showing the cost of 1 to 5 pairs of shoes. Okay, so number of pairs. So if we just bought 1 pair, okay, that's going to be $40. If we bought 2 pairs, that's the 40 plus the 20, which is $60. If we bought 3 pair, that's the 40 plus 20 plus 10, which is $70. If we bought 4 pair, that's the 40 plus 20 plus 10 plus 5, which is $75. And if we bought 5 pairs of shoes, that is 40 plus 20 plus 10 plus 5 plus 2.5, which is $77.50. Okay, so for about 5 pairs of shoes, you basically adding the 40, the 20, the 10, the 5, and the 2.5. Remember, each pair is cut in half. The more you buy, the better deal you get. Okay, so let's talk about this. So the total cost. So the total cost depends on the number of pairs of shoes you buy. If you just bought 1 pair, it's $40. You buy 5 pair, it's going to be $77.50. So the total cost depends on the number of pairs. So the independent variable is the number of pairs, okay, which is your X value. X will always be your independent. Okay, your dependent is your total cost, and dependent is always Y. So if it's asking you for independent, it's asking you about X. If it's asking you for total cost, it's asking you, if it's asking you about dependent, it's asking you about Y. So the total cost is a function of the number of pairs. Okay, so let's write our ordered pairs now based on the results in this table up here. So I'm going to scroll down a little bit. So use your table that you have filled in. If I can get this to scroll down. Okay, so 1 pair costs $40. 2 pair costs $60. 3 pairs cost $70. 4 pairs cost $75. And 5 pairs cost us $77.50. Okay, so that is my ordered pairs. So I'm going to scroll down here a little further and sketch a graph of this. All right, so this here is going to be the cost. Okay, and I'm going to label this one the number of pairs. So 1, 2, 3, 4, 5. Only 5 is the maximum, so that's all I need. Here, it's 20, 40, 60, 80, 100. So 1 pair is going to cost $40. Okay, 2 pairs cost $60. 3 pairs cost $70. 4 pairs cost $75, and 5 pairs cost $77.50. And we want to start at 0, 0. Why do we start at 0, 0? Because that's the beginning. We have bought no pairs of shoes yet, and no pair of shoes means we have no cost. Okay, so then we just kind of follow the lines around. And that gives us our graphing here. All right, so we go on to example 2. A balloon is being inflated with air. As more air is pumped into the balloon, the volume increases until it finally bursts. So here, if we just made the x-axis air, and we made this part the volume, okay, what would happen? So as the more air, it would increase until it pops, and then it would deflate. Okay, so the more air you put into it, the more volume the balloon has until it busts, meaning we have no more air in it, so therefore it's also going to have no more volume. So looking at this graph here, I want you to see if you can't answer questions B, C, and D. So go ahead and pause it, answer questions B, C, and D, and then come back and we'll see how we did. All right, so B, the independent variable, this is the air or the amount of air in the balloon. The dependent variable is your Y, so that is your volume, the volume of air you have in there. Okay, so the volume is a function of the amount of air you have in there. Okay, so if you notice, both times has been talking about the dependent variable is a function of the independent variable. Okay, so that's how it's been both examples, so keep that in mind. So example 3, for a certain time, Lucy jogs up a hill at a steady speed. Then she runs down the hill and picks up her speed. Which graph below accurately represents this situation? Okay, so I want you to pause me, see if you can't figure out which graph you think it is. Unpause it and come back here and we'll talk about it, okay? So go ahead and pause it and answer the question. All right, so at a steady speed, that means we're going to be steady across. And then she runs down the hill and her time, she's going to pick up her speed, so her speed's going to go up. So graph 1 correctly identifies that. Okay, this right here is showing she was going fast and then she slowed down. She was going fast, then she steadied out. The question said we started out steady and then we went down. Okay, so that is why we're choosing this one as the answer, because it starts out as a steady in regards of time and speed, and then it increases also in regards to the time and speed. Okay, so the next example, example number 4, match each table of data to the most appropriate graph, then complete the statement. Okay, so here we have, let's go ahead and label. Remember, your top row is always your X, which is your independent. Your Y is your bottom row, which is your dependent. Okay, so example 4, the height of the falling object. Okay, so here we're decreasing by 4, decreasing by -12, decreasing by -20, decreasing by -28, decreasing by -36, decreasing by -44. And here we're going up by a half each time. Okay, so the graph that represents it down below, if you see the following graphs down here, which graph represents it? Okay, so which graph do you think represents that top table we were just at? Okay, that's the question. Okay, so think about it. When I come back up here, I'll tell you which one it should have been. Okay, it should have been graph number 2. Okay, and so the height depends on the time. Okay, of course, the more time that transpires, the balloon is going to continue to fall, or that falling object is going to continue to fall. All right, so I want you to see if you can't do letter B, the cost of first class postage stamps. That's how you mail a letter. See if which graph you think that is. We know it can't be 2 because we just used 2. And then write down which one depends on which one. So go ahead and pause the video, see if you can't answer those questions then come back and we'll see how well we did. All right, so here we increase by 3, we increase by 0, increase by 0, increase by 4, increase by 0, increase by 3. Okay, so that means the graph down here is graph 3. See, here's a lot of like steadiness. Okay, so that's why it's graph 3. So the cost depends on the year. So basically, it's the dependent depends on the independent, or the y depends on the x. That's how it always falls. All right, so that concludes today's lesson. It was lesson 5-5. Hopefully this made some headway with you and stirred up a little bit of memory, because this is what you did in 8th grade. So go to Google Classroom now. Answer this question. Which variable is your independent variable? Which variable is your independent variable? Thank you very much for watching. We'll see you again.